Hello everyone. In this video we're going to look at configuring GRE tunnels on our G4 based Cubro Packetmaster devices. So those would be the EX32 and 32 Plus, the EX484-3, the EX48400, and the EX20400. If you're looking for configuring GRE tunnels on one of our other Packetmaster devices, there's a video that addresses non-G4 based Packetmasters such as the EX2, since the configuration is slightly different on those. And if you have already watched that video, please forgive the redundancy in this video because I will be repeating myself quite a bit. But GRE is generic route encapsulation, and this is a tunneling protocol that is designed to support any passenger protocol. We'll commonly be seeing this used with IPv4 and IPv6, but it's certainly not limited to that. And one of the common use cases for GRE tunnels is to create a tunnel between two remote sites that would span a public network, and then effectively extend our local area network across the public network. By sending traffic into the GRE tunnel, when it comes out the other side, we're going to have layer 2 information such as VLAN IDs preserved, as well as our private addressing scheme. Another common example for GRE tunnels is that most virtual taps and virtual environments will output traffic on a GRE tunnel, so you will need some kind of tunnel endpoint to terminate that tunnel so that that traffic can be inspected. In our example here, we're going to be doing a pretty basic setup of two EX32s with a GRE tunnel running in between them. And our EX32 on the left is going to encapsulate traffic into that tunnel, where it's going to be sent off to our receiving EX32. We'll terminate the GRE tunnel on the receiving EX32, and at that point that traffic can be filtered or forwarded however it needs to be handled to get where it needs to go. Some criteria that we're going to need when we configure our GRE tunnels is to define a local tunnel endpoint IP address for each of our devices. Each tunnel will have to be bound to a physical port, and we'll need to know the MAC addresses of those physical ports that we're binding our tunnel to. This does require using the command line interface of the Packetmaster, but it's really effectively it boils down to 3 steps. The first of which is defining that local VTEP IP address, then creating our logical GRE interfaces, and then finally just defining the rules that we would use to forward that or receive that traffic, just as though we were defining rules for physical ports on a device. So let's go ahead and get started on that. Jump into the command line of an EX32. And defining our local VTEP IP address is going to be done by going into the config menu and then configure terminal. And we'll type openflow tunnel local and tab complete. At this point, we'll fill this out, local _ VTEP _ IP. In our example, our sending device is going to have an IP address of 10.0.0.1. So if we want to check if this is already configured on a device, if it already has a local VTEP, or if this command was executed successfully, we're going to go back to our config menu, and we can issue a show running config, which is going to give us a lot of output. So let's pipe that into an include tunnel. And we'll see we basically have a repeat of the command that we just entered. So we know that that local VTEP IP is configured correctly on this device. Now at this point, if you want this to persist through reboots, you're going to have to issue the right command, build our configuration, and we're good to go. Let's exit back to our main prompt and create our logical GRE interface. We're going to do that by typing cv add port bridge 0 L2 GRE1. And this is the name of our tunnel. This can be L2GRE1 through L2GRE900. Then a -- set interface, and the name again, L2GRE1, type equals L2GRE, and we're going to start filling in our options. The first, remote _ IP, is going to be the local VTEP that's configured on the device that is receiving this GRE traffic, so our destination IP address effectively. And in our example, that's 10.0.0.2. And then options, bind _ port. I'm going to bind this logical interface to port 4. So I will do ETH-0-4. And then our final option is our next hop MAC address. And this is going to be the MAC address of the physical port that the GRE tunnel is bound to on the receiving device. And we'll just make something up for our example here with a 2.2. Hit enter and make sure that our spelling is correct. Way back there at the beginning. All right, now we have our logical GRE interface defined, and there's a few ways that we can check this. We can do a cc dump ports bridge 0, and while this device does have quite a few ports, somewhere in here should be a port 201, which I can see is right up there at the top, but I keep scrolling past it. And there's our port 201. So this is our logical GRE interface. Another way that we can check that is by doing the ovs-ofctl command, show bridge 0, and we'll see that the output is a little more ordered in this one. There's port 201 with the name L2GRE1 defined. Now, of course, we can define multiple logical interfaces on a single device. So we can do another GRE interface by changing the name. So L2GRE2, for example, set interface L2GRE2, type equals L2GRE2. Now, there are two limitations to creating multiple tunnels on one device and having that tunnel actually be valid. And that's that you can only bind one tunnel to a single physical port, and every tunnel must be defined with a different remote IP address. So let's say we're going to send this off to an endpoint with a VTEP of 10.0.0.3, and we're going to bind this to port 5. Now, if we do that ovs-ofctl command again, we're going to see that we have a logical interface of 201 and 202 for our L2GRE2. And the naming convention here is that L2GRE1 becomes 201, L2GRE2 becomes 202, L2GRE3 would become 203, and so on and so forth. Another command that's really useful in seeing what tunnels are configured and how they're configured is to drop into our config menu, and let's do a show interface tunnel brief. And you can see that this shows us all of the information that is assigned to our two GRE tunnels that we've just configured. Get back to our main prompt, and at this point we can start creating the flows that are going to send traffic through that tunnel. So a cc add flow, bridge 0, import, let's say we want to take all traffic in port 1 and send it down the GRE tunnel. Import equals 1, actions equal output to our logical interface of 201. So this traffic is being carried across the physical port 4, but traffic that's directed at port 201 will be encapsulated inside of that GRE tunnel, and traffic that's simply directed at port 4 won't. And just a note here, we can see that these rules do appear in our web GUI, even though we have to use the CLI to define this, but you'll see in port 1 and out to port 201. And we can also take a look at those GRE headers by grabbing a capture of that. So let me start up a capture, and I'll send some packets into that tunnel. That should be sufficient. And we'll see that we have our additional 38 bytes of GRE header right here. Now, just to demonstrate my point, if we were to delete that rule, so cc delete flows, bridge 0, and redefine that rule as simply out port 4, when we take a look at that capture, we can see that none of this traffic has a GRE header assigned to it. Now, another important thing to mention here is that we can use all of the same input filters that we would for setting up traffic flows any other way when we're outputting to a GRE tunnel. So for example, if we wanted to send only traffic destined for a specific IP address into the GRE tunnel, we can do that simply by doing a cc add flow, bridge 0, in port, let's say 2, and the IP protocol, and IP underscore DST for destination IP address, and let's just say like a 192.168.1.2 or .2.1, that works too. And then actions equal output to our logical interface of 201. And once again, we'll see this in the web GUI, filtering on a destination IP address, outputting that to the GRE tunnel. So this is all of the configuration for the sending device. Let's remove all of this stuff and then configure what we would have for the receiving device. If we want to delete a GRE port, we would issue the command cv delete port bridge 0 and then the name of that port. So we have two. We have L2 GRE2, which is now gone. If we were to try and do a cc dump ports bridge 0 and then grep that for our port 202, we will see that we don't get any output because it doesn't exist anymore. And then also if we were to drop into the config menu and issue a show interface tunnel brief, we only have one GRE tunnel at this point. When we delete a GRE interface, we'll also delete all rules that are associated with that GRE interface. And then let's just get rid of port 201 as well. L2 GRE1, and it's gone. So all of our GRE tunnels and all of our logical interfaces are deleted at this point. However, this device still does have that local VTEP IP assigned to it. If we want to remove that, go back into our config menu and then back into configure terminal, and we would say no openflow tunnel local VTEP IP. Now we've removed that VTEP IP address, and we can confirm that by checking the show running config again. In the include tunnel, we'll see it returns no lines. That's no longer in our config. And if you wanted to save that, of course, you would issue write. But that's removing all of the information. Now let's set up the receiving device as per our example. So again, configure terminal, openflow tunnel local VTEP IP, and our receiving device had a VTEP IP of 10.0.0.2. Exit, back to our main prompt, cv add port, and I'm going to use command history here just to save a little bit of typing. L2GRE1, and the remote IP is now going to be the VTEP of our sending device, so that's going to be the .1 address, and in our example we're going to bind our receiving tunnel endpoint to port 1 on this device, and of course we would have to adjust the next hop MAC to the MAC address of the physical port that is sending the GRE tunnel. Again, we can use something like our OVS OFCTL to confirm that we created this interface successfully. And there it is, port 201. And now simply the flow to receive the traffic. Now, if you've watched the video on the non-G4 based devices, there's an additional step in those where we actually have to terminate the tunnel specifically and then receive traffic on the logical interface. On the G4 based devices, we don't have to do that. So we simply do cc add flow, bridge 0, import, and our import is going to be our logical interface of 201 to receive traffic on the GRE tunnel, and then actions equal output to wherever we want this traffic to go, say port 20. And once more, this will show up in our web GUI as soon as this refreshes. There it is. And that's all there is to it. So between these two videos, you should be able to set up GRE tunnels on any of the Cubro Packetmaster devices. Yeah, and that's about it. Thanks for watching, everybody, and have a great day.